Good morning. My name is Wenming Yi. I'm a technical evangelist on the Windows Server evangelism team. So today I'd like to introduce you to a new feature of the Windows HPC Server 2008 R2 SP1. First, let's take a look at how a traditional HPC cluster works. On the PowerPoint here, you can see that we have an HPC head node that controls a cluster ranging from 1 to 1,000 nodes. So for a user to interact with the cluster, they will have to submit a job through the HPC job scheduler that sits on top of the HPC head node. And then that work is farmed out according to policy and scheduling mechanism to the HPC cluster. So about 6 months ago, we released our 2008 R2 product, which allows you to farm some of that work and offload that onto a desk compute cluster, if that is available. So many corporations and universities has compute nodes or workstations that are sitting idle at night. So you'll be able to schedule these workstations to become a compute resource when they are idle. So for SP1, we added an even better feature, which allows you to offload your work onto Windows Azure nodes. So these nodes are typically compute nodes, and what you're allowed to do is to take your work, submit it to the HPC job scheduler on the head node, and then farm that across to Azure and distribute it onto the worker nodes on the Azure cloud cluster. So let's take a look at an example. Here on my desktop, I fired up the HPC administrative console. So for those of you who are familiar with the console, it looks exactly like it was in the previous versions. So here's a configuration panel where you can add and remove nodes and config network, job template, users, service, and iSCSI deployment. And if you take a look at node management, you'll be able to see that I have quite a few nodes already running. So what you will notice is that on my original cluster, I had 6 on-premise nodes. So these nodes, each of them have approximately 8 cores. So I have a cluster of 48 cores running. So I have 2 of these nodes actually offline. So I really have about 8 nodes that are on-premise. So these nodes have InfiniBand connecting among them. So what that means is you would be allowed to do engineering workloads that demand high bandwidth between the nodes. So you also notice that I have some Azure nodes that I spun up. There are 10 of them total. And these nodes are 8 cores each as well. And if I want to add Azure nodes, it's quite simple. I can just simply right click and say click on Add Nodes and go to Add Azure Nodes, and I can select between 1 and however many your subscription allows. Plus, you can also choose either small, medium, large, or extra large instances. Extra large instances are my favorite. They have 8 cores, and the small instance has only 1. So here I already spun up approximately 80 cores. So let's actually submit a job and to see what it looks like. To submit a job, the easiest way is to also go through the management console. Let's go to Job Manager. As you can see, I already have a lot of jobs that I have run through the cluster, but there are no jobs that are currently running. In order to submit a job, I can select New Job from the XML file. I have one that has been pre-arranged. So let's first talk about what this job does. Essentially, I have 400 frames that I would like to render entirely on Azure. And those 400 frames will have to be made into a movie. And what we currently have are the descriptions of these ray tracing rendering jobs. These files are called RIB, has an extension of RIB. They're essentially renderman compatible files. And my task looks like the following. If you're familiar with the parametric sweep engine, it's really easy to run. So we want to run the same command 400 times and vary the parameter by the actual file that we're rendering. So if you type in the command in the command line, you will see in step 4, it'll automatically generate what your command is actually going to execute. So in our case, we're going to run the run.command frame 01 through 400. So those are the command and argument that we're looking for. And also here in the working directory, we specify it's going to be using the environment variable, CCP, or CCP is really a legacy acronym, which stands for Compute Cluster Path, I believe. And if I cancel that out, and let's take a look at the actual command we're going to run. So here's the actual command that we're going to run. It's called run.command. So as you notice, it differs a little bit from if you were to try to run the same command on a regular on-premise job. If you were to do that, I would simply run this particular command, and nothing else would additional things would have to be done. So running aqueous-shader, essentially, this is the command that you would be running on each of the frames. But since we're actually working on Azure, there's some additional things we'll have to do. First of all, you will have to copy the file from the blob storage. This is the first command, to simulate a file share. So what I call this is a sandwiching your command with a pair of copy commands. And of course we added a winr, which unzips the file for us. So winr is wonderful in this case because we want to save the amount of files that we want to store on the blob storage, and also saving this amount of space we're taking up. So in order to run that same command, you will have to do the following things. First, you copy your job. You copy the file that your job is going to work on and copy that onto the local node. And the second command is that you run winr. You unzip the file that you want to run. And the third, you do the actual rendering command. And finally, you want to run the Azure blob copy command to copy it back onto the blob storage. The reason we're doing this is because the local directories or hard drives are not persistent. Once your job is done, you can take down those nodes. Those files will no longer be there. And keeping everything on blob storage would ensure that all your jobs will be there, and you can use them for further processing. So let's take a look at what's actually sitting on the blob storage, especially the input file we're going to run through. So the program which I like to use is the Cloudberry product, and you can download that freely from the Cloudberry website. So if I choose my storage, which is the storage that I'm working out of, the input directory or the input storage container has all the frames that I'm about to render, and these frames essentially each of them consists of a rib file. And if I open up one of them, and you can see that their actual files are much larger than what the actual compressed image on the disk. So that really helps us to save not only transferring, but also the amount of storage that we're going to use. So here's frame.rib, and our job is to run through all these 3D description files and produce a movie at the end. So let's actually go ahead and do the rendering. So I'm going to open up, go to Job Management, open up the file again, and hit Run. As you can see, as soon as I submit a job, you can take a look at the active job category. You can see it's already running. If I double click on it, you can immediately see that I have 80 jobs currently running and 321 in the queue. What that means is that I have 80 cores. Each of these cores are working on one of these frames. So the most fun part of this demo is to actually take a look at the node management, and as you can see that a lot of these nodes are starting to really light up in terms of the CPU usage. As you can see that Azure CN1037 is showing a pretty good CPU utilization at 100%, and the rest of them are also catching up quite a bit. I have utilization ranging from 45% to about 68%. So since these nodes are actually running on Azure, it takes a little bit of extra time for them to for the heartbeat and the performance information to be able to propagate back to the management console. As you can see, all 8 nodes are now running at 100%. Actually, I have 10 nodes. What that means is I have 80 cores working very hard on the 400 frames that I currently have. So if I were to run the same job on my laptop, it would take me 10-15 hours to do. But on Azure, the entire job would take you no more than 10 minutes to finish. So let's actually go back and go to the job management tool and see, we'll be able to see that a lot of jobs are already finishing up. I have 99 of them finishing up and 80 running and 222 in the queue. And once the job finishes, we will be able to see the movie. So to save time, I have a movie that I pre-rendered already, which you can see. It's sitting on the blob storage that I previously showed you. So let's actually take a look at the output directory to see the actual cluster is really working on it. So the current clock is at 10:54, and you can see that if I sort it by modified date, you can see these frames are being output as we speak in real time. So if I hit refresh, you can see that more and more frames are being finished. So let's actually go back and take a look at the movie that we generated. Here it is. So I'm taking a little bit of time to download the actual movie from the Azure Blob Storage. As you can see that this movie is playing back a little CO2 race car that actually used the engineering product that we also helped to make here at DPE, and won a first place at the Australian CO2 car race. So this is basically my demo. Thank you very much for watching, and if you shall have any questions, please do send me an email, and I can be reached at wenmingyi@microsoft.com. Thank you. Bye.